Yeah, another DraftScience video presentation. Yes, going over the basics. The regular physics just made a hell of a lot of mistakes, frankly. They don't explain any of this stuff completely. Let's say, what's the word they use? Yes, incomplete. That's the word Einstein used when they would talk about their quantum mechanics or something, and they would like to say it's all garbage or something. Instead, they would say, there seems to be an incompleteness. you know, a lack of coverage, it doesn't add up. You're not really getting to the core of it. So anyway, we have these Newton principles, which are nice, okay, these laws of Newton's, but they're, depending on how you, interpret his Latin, whatever, you phrase it a little bit differently, it can mean something different. And of course, even English language changes over time. And words can be subtly reinterpreted and understood to mean something different. So I'd say the principles are okay-ish, but they're just principles. They're not really laws. They're themes, suggested something or others. So anyway, let's go over some of that first. Just simple stuff that gets to this, some of why there is any confusion when there really shouldn't be any argument, because all of this has to be understood in some sort of context. Okay, so I have pointed out before, like movies like Interstellar are just the worst physics imaginable. I mean, it's just horrible physics just for storytelling. Okay, and this is now a Nobel Prize winning physicist, and the physics is just horrible. So they have a nice little phrase in the movie where they talk about how you have to get somewhere, you have to let something go. So there's this little part in the movie where, the spaceship is trying to get enough speed to escape the black hole. And so it has extra little ships on it, and so it gives the little ships away. It detaches them, which means absolutely nothing. It's just merely detaching is not going to give you any more velocity. So if you give it away by just saying, bye, I'll see you later, losing mass doesn't do anything unless, afterward you were going to, turn on your big rocket and, now you have less mass, so your fuel will go further because you've gotten rid of some of your weight. So that would help. But in this case, it was after they used the little ships to do the pushing. So they used the little ships to do the pushing, okay, and then they detach them after and that's, and this is the guy stays in the little ship here, little girl's in here, and saying, oh no, you're leaving me alone, oh. It's a big tragedy, and it's just the stupidest scene because he's just drifting away. Just drifting away will not solve your problem. If you need more fuel, you've already got your momentum with your mass, and just getting rid of mass won't give you any more momentum. It just doesn't give you any more speed. It just doesn't work that way. The ship is already going the same direction you're going. It has the momentum in it, and when you detach it, it still has its momentum. It's just going to drift along with you. Even that part doesn't make any sense, right? In the sense that he detaches when the rockets are off, so they both have their momentum. You detach, you don't even go anywhere unless you detach violently. You're not going anywhere. So the idea is that in some cases you need something to push against, and this is where I tried to explain the other day with you need pressure, you need to trap energy. And the whole idea is if you have it trapped, it hits this side, and it bounces back and hits this side, and it bounces back and hits this side. And you can sort of get the idea that, oh yeah, every time it hits this side, it also hits this side. So it's pushing you in both directions equally. And that the trick is to, open this up a little bit so it hits you on this side, but there's no equal and opposite reaction. So you're almost avoiding the equal and opposite reaction to actually go somewhere. So, yes, Newton's right in this picture. So if you look at it from here, yes, it's equal and opposite forces and reactions and all that stuff. But if you look inside at what really has to happen, it's exactly the opposite of Newton's principle or law. What you're trying to avoid is the equal and opposite reaction. See, if I could So say I have a pressurized container, and now what I do, so you understand the principle. There's stuff bouncing this way, and there's stuff bouncing this, there's pressure. And so I want to somehow maximize, I want to get a direction out of this. So I got no direction because things are going back and forth, right? Well, the trick would be is to very, very quickly get rid of this wall altogether. Then what happens? Well, everything going this way, well, I lost that, okay? You can't do nothing. But every single thing going this way, there'll be no opposite reaction to it, right? It won't hit a surface going the opposite way. So every single bit of energy going this way, okay, is going to hit this wall without a reciprocal, oh, I hit this wall too. So there's not going to be any yang for the yin, or however you want to look at it. So all of the pressure, all of the energy, the momentum of all the little tiny bits, right? So the stuff going this way, like I said, you lost that. It doesn't mean a damn thing. So half your energy just left. But half your energy is now going to hit this wall. It's going to bounce off, and there's going to be absolutely nothing this way. So there won't be any opposite momentum imposed. So you're just going to have momentum hit you this way, and every single bit of it's going to hit you. So you're going to be hit with a lot of pressure in one direction, no pressure in the other direction. Therefore, you're going to go really fast that way. So if you open it up with just a little bit, then you'll create 10 of these extra hits this way with no hit that way. And you open it bigger, you got 100, you got a bigger thousands. So, and that's the principle. So it's not really an equal and opposite reaction, is it? It's technically you're getting rid of what pressure means. Pressure means that you're creating something where you've trapped energy, and now you're breaking the trap, and so in a sense you're getting rid of one of the actions and only getting one of the actions hitting you. So you're just changing what's hitting you. Okay, so then if I want to gain some momentum by getting rid of my mass, if I have mass and it's disposable, I can just get rid of pieces of it like a little spaceship, and I'm going somewhere. Well, the trick is to say if I want to go that way, well, okay, I can take this little piece, and what I need is like a fulcrum or something. I need to push it away from me. I need to create pressure between it. Okay, so let's just reshape this. So I want to create pressure between it and my surface. I want to create some kind of unfolding fulcrum, some sort of little elbowy thing that pushes it away. And what's going to happen when it's doing that pushing? Well, it's obviously going to push on my surface because I'm creating something with pressure, right? I'm creating a little explosion. I can create it mechanically, or I can create it with dynamite. I can create it lots of ways. But what I want to do is just create the pressure thing. I want to create the pressure thing that's pushing this way and this way. It's pushing on both sides, and all of the pushing is in the opposite direction. So I'll get all the pushes this way, okay, and this thing will get all the pushes this way, right? And what I've done, in a sense, that's all I've done. I've just separated the two impulses, an impulse going that way and an impulse going that way. But I have to shoot this off. And now the more pressure I create in here, the faster I can get the small bit to go away. I'm giving the equal momentum. So yes, this will lose half. It'll get half the energy, and this will get half the energy. Okay, and this does with its half, because it's much smaller, it goes faster velocity, and because this is much bigger and you have to spread the energy across all of the atoms, remember every single atom has to be moved, so you have to spread your half of the energy over this big surface. This has a little tiny surface, so obviously this one's going to go faster because the energy is going to be more effective. Okay, but they each get half of the energy. That's the way to look at it, in my opinion. You don't look at it as equal and opposite reactions. They're splitting the energy of the pressure. That's all they're doing. They're splitting it. So I mean, this is, there's subtleties here that they're just not appreciating at all. This is, this is physics, and because they have no explanation of gravity, right? They can't give you this simple explanation for what gravity is that your mass is a bucket, okay? And if you have a lot of mass, you have a big bucket, and you're just collecting gravity. You're just collecting a constant rain. So if your bucket's big, you collect lots of water. If your bucket's small, you collect a little bit of water. And so that obviously is going to affect you when you're moving into the rain. The big bucket's going to collect a lot more, a lot quicker. Real momentum, real force, real weight of water. It's going to fill up the bucket quickly. This one's not going to collect, mass of water. And this one's not. And you need a certain amount of water to equalize the momentum, whatever your spring you pushed up with. You need to collect a certain amount to equalize the pressure that pushed you. So if the pressure pushes you as a 10, well, obviously this one's going to reach 10 really quickly, and this one's going to take it a while to reach 10. Come on. That's the real physics, okay? I'm giving you a little clue. The physicists won't say any of this stuff, but that's the real physics. That's what's really happening. You can't just use some flat law. Newton says. And no, it's you have to understand that pressure is giving energy in both directions. That's the nature of pressure. It's pushing both ways. You can't really have pressure without pushing both ways. And you're just saying who does what with their half of the energy. Both are going to get half the energy, and what are they doing with it? What can they do with it? And the only thing they can do with it is apply it to their velocity, because they can't change their mass. Pressure is not going to change their mass, so all they can do is apply it to their velocity. And how do you apply it to their velocity? Well, you move every single little bit inside of them. Every single little atom has to be equally disposed with this extra pressure in the direction. And so if they in the stupid movie would have shot the little extra launcher, like they turned it around and put its rockets pointing at the ship and it shot off or something, you might be able to make an argument that somehow you could gain some velocity by losing a piece of yourself. But you can't lose it unless you create an energy mechanism, a pressure mechanism between you and the ship. If you don't do that, it just won't do you any good at all. So there's absolutely nothing, there's no you have to leave something behind bullshit. You have to shoot something behind. You have to allow some pressure to be relieved in that direction. And so you have to create the pressure first. And you can't create pressure with nothing. If I just put pressure on the outside of my ship and just shot pressure, okay, in the sense that I just put a stick of dynamite or something, well, I'm still going to get half the effect, so it'll still work. But let's see, how else can I say? Yeah, but you really have to create the pressure. You have to create something that is, going to shoot little arrows at you. Some sort of little bits are going to hit you. So you have to create something to do that. Like I said, I could put a light bulb out there. Well, obviously the light bulb's shooting this way, and there's lots of wasted energy, so it's not a very effective way of trying to move my spaceship. All right. Yeah, so the idea though is you really do have to push against something, in the sense that you have to be allowing the pressure to escape in a direction by essentially removing a wall that was preventing it from leaving before. You have to get rid of the direction you don't want. The way to get rid of the direction you don't want is just to let it go. But it has to have the direction you don't want. When the ship is connected to you, it doesn't have the direction you don't want, okay? It has the direction you do want, and the direction, it has both. And so you have to find a way where it leaves behind this direction and it takes with it that direction. Until you do that, you're not going to gain anything by just cutting your foot off while you're free falling. It's not going to make you go any faster. Alright. Well, see, even that has a technical, technically, yes, because of air resistance, it might make you less resistant to the air pressure, so you don't build up quite as much air pressure, so you might be able to reach a tiny bit faster velocity if you have less surface area. But it has nothing to do with space and all that kind of crap. It won't do you any good in space. If you're a space guy floating around in space, cutting your leg off won't do you any good. You could cut your leg off and then throw it, using your arm as a pressure fulcrum, okay, and that'll do you some good, but obviously it's not going to get you very far. Anyway, So their physics is just garbage, and I shouldn't have to keep arguing this crap, but whatever. It's so bad, and these are people that they're just so caught up in their religion, and all they can do is recite the verses from their Bible, and it's pathetic. So I'll just read some of this again for one more time. I didn't say anything about energy, so it's just hilarious, right? I mean, the whole controversy was about energy. So let's not be fooled. I mean, they didn't have the word energy yet, right? So that didn't come till 15 or something. So they didn't use the word energy, but they were clearly talking about this this force or this thing that gives things motion. Okay, so it was clearly understood to be energy. Now, they really didn't think, and they hadn't connected heat as a form of energy yet, and all that stuff. Obviously, they didn't know atoms explicitly existed, and they certainly didn't know about electrons and protons. So, but clearly, the conversation is all about energy. I mean, the literal translation is living force. Okay, so come on, get real. I told you, use only Newton's second law. So again, why would I only use something that doesn't even say anything accurately, right? I mean, F equals ma is a nonsense formula when you're talking about objects, where the kinetic response is so quick, where the transfer of energy happens so fast that acceleration is irrelevant. It's a full transfer of momentum. It's a full transfer of velocity. So how in the hell does acceleration have anything to do with it? We're talking about bodies that move, that's theoretically moving in space, and they have momentum. Two asteroids banging into each other. Let's get rid of all the friction bullshit and all the other nonsense you want to pretend has something to do with this. And we're just talking about two asteroids colliding. All right, and the fact is that has in it, and it doesn't matter which one's moving, the whole relative, it doesn't matter. Whether I'm running into the bullet at 10,000 miles an hour or the bullet runs into me, the equation for what's going to take place is the same. The physics is the same. It doesn't change. We're just talking about two things with different potentials. I mean, different vectors of momentum. Anyway. It's just too stupid. Anyway, and see what the prediction for the problem. So it doesn't have anything to do with that. You have two different definitions of the same thing. Momentum is energy. There would be no point even saying the word momentum if you're not going to say it means something, if it doesn't mean anything. You might as well just throw it in the garbage can if you're just saying momentum doesn't mean anything. It clearly means something. It means something's carrying vectors of capacity to affect other atoms in the universe. That's what it's doing. It's matter moving. And that's really important. That's the definition of energy, frankly. I mean, it can't be stated any clearer. You have two competing definitions for the same thing. That's the real problem, and you're pretending you're talking apples and oranges. No, there's no apples and oranges here. There's just the concept of what makes something move in the universe. Well, it's because something hits something else. And that's the truth. The electron has to travel to the other atom to ionize it. Things have to move to the other thing and actually hit it. Okay. They have to hit into the system. Yeah. All right, second law, and see what is the prediction for the problem. So again, we've already been through that. There's two different answers for what the thing has for energy. Momentum gives you one answer. The kinetic energy formula gives you another answer. The answers are not in any way compatible. Okay, the prediction is that the spring will not compress the same. So again, that's his statement. So let's just understand what he's defending and how it's absolutely ludicrous. So that's all I can do is say, no, you haven't dealt with anything stated. And if you're going to claim this preposterous theory of yours, okay, we have one spring. We compress it a certain amount. It's reliable, like a scale. It gets the right answer. When you step on it one day, it doesn't give you a completely different answer, okay? So a certain amount of compression of the spring is a certain amount of energy. Just a fact, okay? So whatever you call it, 100 joules, it doesn't matter what amount we give that. And we shoot a light thing and we shoot a heavy thing, right? So a 2-masser and a 1-masser. And we know this one's going to go twice as fast. So this will go 2 velocities and this will go only 1 velocity. All right. Now, the simple truth is, okay, momentum says these two things are equal. Equal force pushed them. They gained equal amount of energy. It was rather efficient. They might have lost 1% of their energy in the process of heat and skidding and other little factors. But the fact is you basically converted the stored energy in the spring and you converted it into motion of the two objects, and you gave them both the same amount of motion power. Okay, and it's just that the power has to be spread over lots of atoms here, twice as many. Okay, so it can only go half as fast because it has twice as many little bits to push. All right, and the simple truth is that if you bang these into another spring, it'll compress the spring exactly the same amount. Okay, just no doubt about it. You'll get the same energy from this that you get from this, the same compression, the same storage. All right, there won't be any different. Now their formula says this has twice as much energy. So even though this can only deliver 100, they say it has 200. All right, that's what their formula says. Their formula says this has twice as much energy as this, even though it's the same spring and the same spring. They're saying that somehow it has it. Now I'm saying there's not an experiment on Earth, there's not a single experiment anywhere conducted by a human being that will ever demonstrate this. A credible experiment. Like I say, I can drop crap into a blob of clay, and because clay lets fast things go deeper, okay, you can say it's more energy, but I'll argue, no, if you calculate exactly how many atoms moved in the clay, right, see, it's too bad that the, in the whole process of this was the same time as the French Revolution. And there's actually a guy who was the tax collector, but he was actually a good scientist. He did all these experiments where you put everything, put the whole experiment inside of a closed bell jar or something, and he did it with really technical experiments to see exactly how much, like he just stirred water and figured out how much heat was created, and then he evaporated like a frog, and then he added up all the crap that came out of the frog evaporating and proved that the whole frog was in the air now and it was all these other places. And they cut his head off. Now that was pretty dumb. I mean, he was a tax collector, so that was a pretty stupid thing for a scientist to be doing. But if we had that guy, then all of this whole conversation wouldn't take place, because that guy would have said, you can't do it with clay. Clay is going to tell you the truth. I can't just use clay in my lab and just say, well, I'll just see how far it shoots into clay and that'll tell me how much energy it has. He would mock that and laugh at that and say, no, you got to count all the little vibrations you're creating. And you're creating a ton of heat and vibrations inside of clay. So it's lying to you all over the place. You don't do this experiment with a blob of clay. All right, you have to find something that's really more reliable at collecting energy. And clay isn't the thing you want, because it won't show you the energy that's in it. It won't show you how hot it is. It won't show you how liquid it got. It won't show you any of that. And so it'll give you this false impression that, oh, because you went deeper, you made more heat and more energy. No, you didn't do all those things. The fact is the less deep you go, the hotter it got. Okay, and the deeper you go, the less hot it got. So it's not telling you the truth. I shouldn't have to explain this to people who care about physics, who have thought about it for 15 minutes maybe. See, I've thought about it for hours and hours and hours. So I mean, it's easy for me. But anyway, this is the simple truth. This is not equal. It doesn't make any sense. They'll never collect this extra energy. Again, if I put a little turbine on the heavy thing and a turbine on the light thing to collect how much energy they have, how much they can spin a motor, how much torque they can create, they're going to create exactly the same 150 watts, whatever it is. They're They're going to collect exactly the same amount of energy from a generator. They're going to produce exactly the same amount of energy. This is just nonsense. Momentum is watts, it is joules, it is all of these things. It's completely convertible into them. It's real energy. Momentum is always the energy. It's the energy of an atom. It's the energy of an electron. It's the energy of a photon. And it's the energy of a human being. It's all about your motion, your velocity, and how much mass you have. It's all about having little bits, and they have to be moving somewhere, causing pressure. And he didn't deal with that paradox at all. I mean, the simple paradox is right, I just roll the big thing into the spring, compress it, replace it with the light thing, and the light thing has more energies by some magic. By some absolute magic, I made extra energy by just shooting the light thing with the compression I made with the heavy thing. I put a generator on the heavy thing, collect the electricity, and somehow when I apply that electricity to the light thing motor, pushing the light thing, somehow the light thing makes more energy. Now, yes, it'll go further because it's lighter. Of course, it's easier to push, and it'll go further, but it won't use up more watts. Okay. Problem. Okay, will not compress the same. All right, so the prediction is that the spring will not compress the same. So he's saying when I smash the one mass thing with the two velocity and the two mass thing with the one velocity into the same spring, he's saying they'll compress the spring a different amount. That's just absolute silly crap. So he'll never find that experiment ever. And that's just a fact. And just like in the spaceship, if I was flying in a spaceship and I had a certain amount of releasing energy, right? So I'm going to have a little explosion, and I'm going to get rid of a one mass thing on this side, and I'm going to get rid of a two mass thing on this side. And I'm going to use the same exact explosive, right? The truth is yeah, the one mass thing will leave faster. So what? The two mass thing weighed more. So the pressure on my ship is going to be exactly the same. I'm not going to go anywhere. So if I shoot a one masser off here at twice the velocity and a two masser over here at half the velocity, I'm going to get exactly the same amount of pressure from each explosion, and I'm just going to keep on going straight. That's the real physics. I don't know. It's just, I have no explanation for why physicists are really dim, but apparently they're some of the most unobservant people on Earth, because here they are looking at this stuff all the time, and they can't figure out, why do we have two formulas for the same thing, and why are they getting different answers? I mean, having two formulas is one thing, but two formulas and getting different answers, that's really stupid. Okay. But again, it seems you don't know what is Newton's second law. So he just keeps talking as if this stupid second law, which can't even apply in 90% of circumstances, in the sense that the conversion of your energy from one object to the other object is so quick, acceleration can't mean anything. Acceleration, again, is just measuring a change in velocity. Well, the whole argument here is we're talking about things that already have their momentum. We're talking about things already moving in space. The asteroid is moving in space. It's been doing the same thing for 1 million years, going exactly the same speed for 1 million years. Acceleration has nothing to do with this. All right. Newton's second law, don't talk only about gravity, so you are the one who is lying. So you're trying to make the argument that Newton wasn't in that part of what he was talking about, wasn't talking about the fundamental laws of motion in the universe. Well, I think that was that section of his, it was in 3 sections, the Principia and, all this kind of crap. But I think it could be rationally argued that when he was establishing these rules, they were mostly in the context, okay, of how the universe functions. The big universe. The celestial universe. But anyway, it doesn't matter. It really doesn't matter. I don't think there's any way that Newton is telling you F equals ma is really important when it comes to, steel balls colliding. That somehow, what happens with the acceleration, when the two balls hit each other, is somehow the important bit. No, the important bit is that all the energy goes into the other ball and it doesn't go higher. Okay, that's the important bit. And you can't ever make something go higher with the same amount of mass. Theoretically, you can make a lighter mass go higher, but you can't make the same mass go higher. And you certainly can't make more energy by banging things into each other. All right. So I said, you haven't dealt with the free energy paradox that is the implication of your beliefs. Right. I just replace heavy things with light things and I make more energy. Free energy. So he says, there is no energy paradox. Of course there is, but anyway, you will not lose or gain any energy. Well, your formula says you do. So see, this is the ironic part, right? We just have the same spring push two objects. We know this one's going twice as fast, and we know his kinetic energy formula says it's twice as much energy. So how can you in 1 minute say, you have to defend the fact that you're saying the same spring can produce 200 joules or it can produce only 100 joules, depending on how heavy the object is I put on the spring. You're saying the spring is incredibly efficient when it's shooting things fast, but it's incredibly inefficient if it's shooting a slow thing, a heavy thing. So if I have a heavy mass, somehow I lost all the energy. The spring got much, much hotter. Some kind of bullshit happened. You won't be able to explain what that bullshit is, but somehow I lost twice the energy. Just like with the stupid trains sticking to each other analogy, you're telling me I lost half the energy. Okay, I bang one train into another train. Okay, and then they both go off at half the velocity. You're saying half the energy was lost. Did you explain to me where half the energy went? I mean, the trains must have got red hot because it's a hell of a lot of energy. Okay, I mean, a train going 10 miles an hour and, that's a hell of a lot of energy. You're saying I lost half of it. Anyway. If the body with 2m collide and compress the spring, then the kinetic energy, it will become deformation. So they just keep using this word deformation, right? Now we know the spring compressing is not deformation because it's completely coherent. Okay, it's a tricky word. It's completely coherent storage of the energy. You've stored the energy in just one direction. Deformation means you're converted energy going this way into energy going that way. That's deformation. Just like, water waves or something else you could argue is a kind of deformation. The only trick is gravity fixes the deformation, so it doesn't matter. You get your energy back. But deformation means you've converted energy from in one direction into energy in another direction, and you're not going to necessarily be able to restore it back into the direction you need. So it's lost energy because it's going somewhere else in the universe now. It's a vibration, and it moves through the floor, and it goes this way, it goes that way, it goes all kinds of directions. So you've converted the energy into losses to heat and all that stuff, which are deformations essentially. But you don't call the compression of the spring deformation. And you certainly don't call it deformation energy, because the fact is it's very coherent to the direction. You push this way, you're going to get back that way. Okay. So again, he's really is arguing that the spring loses twice as much energy by doubling the mass. So the heavier thing I'm pushing with the spring loses half the energy. And it doesn't lose half the energy with the other object somehow. Magically, the light things don't lose half the energy. It's just too silly. All right. Spring, then, its kinetic energy will become deformation energy to the spring. If now take the 2m body and change it with one mass m, the deformation of the energy spring, it will become kinetic energy of the lighter body, but it will have the same joules. So we know it doesn't have the same joules. So he's just so overtly cheating. We know it can't have the same joules because it's going to push the lighter object twice as fast, and your formula is going to say it has twice as much energy. So you're just overtly lying. You're cheating. You're saying something that your own experiment can't say. My experiment certainly doesn't agree with it. So you're not even coherent to any kind of rational details. You cannot change the facts. You can't pretend that, well, yeah, it's going twice as fast, but it's, same amount of, same momentum, but you're overtly saying it has to have different kinetic energy. You can't just say it has the same energy, the same kinetic energy. Your formula says they have completely different kinetic energies. Anyway. So let's say body 1, mass 2, and velocity 1, fine, and velocity 2. So the kinetic energy of body 1 will be 2mv1 times, what he does this thing. If body compresses the spring, its kinetic energy will become deformed. He said it again. So now he's got a spring constant in here that somehow he thinks is going to get rid of half the energy. No, you can't do that. So again, it's just horseshit. I mean, it's quite obvious. You're over. I mean, I can't make it any simpler. The same spring compression applied to two different objects. We already know what the objects are going to do. You can't say that the slow one went slower. you can't change the basic facts. The one of them's going to go half as fast as the other one. And because you're squaring the velocity, that means it has to have twice as much energy. Anyway, it's just too silly. Anyway, the spring, this energy will be transferred to kinetic energy for the lighter body. So, so at the end, if the body 1 had 250 joules, then body 2 will have 250 joules. So it just doesn't make any sense at all. It's impossible unless you somehow speed up the heavier object. It can't have the same joules. It's just impossible. So you're crazy. I don't even know why I shouldn't even bother. I should just block them and say the hell with it, because that was just such a convoluted pile of mush. You can't change the basic experiment. You can't change the rules in the middle of it. All right, anyway. And none ever said that the energy, it will become 500. You are the only one who said that. I'm saying you can't change the physical facts and say they add up to something different. You can't say I mean, I know I did your formula correctly, so it's just a lie to say that somebody did a mathematical error. Okay? It's 1/2 mv squared. There's no way the lighter object going twice as fast can have the same amount of energy as the heavier object going half as fast. Your formula says that one has to have twice as much energy. So you're just full of shit. All right, so your paradox you are referring to comes from your ignorance. No, there's no ignorance here. And again, no experimental evidence. Not a single experiment ever collecting this extra energy. We'll never find one because it never happens. It doesn't exist. Blah, 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 blah. So I said something amazing, but I don't know why I bothered even replying. You're just ignoring the facts of the experiment. The spring doesn't care how fast or slow you compress it, right? Everybody knows the spring doesn't care. I mean, I could push the spring really quick to a point, or I can push it really slowly. If spring doesn't care. And likewise, when it's expanding, it doesn't care. Now, clearly, it can only expand so fast. So if you put something really, really light on it, the spring might not be able to give it the full velocity because the spring just can't move that fast. All right, it just cares about the compression. Deformation will not be any different for the light object or going fast or the heavy object going slow. To conserve momentum, the object with half the mass must have moved twice as fast. So you can't say momentum is conserved and yet the heavy thing and the light thing have the same kinetic energy. It's impossible to do that. You can't conserve the momentum and say that two different objects have the same energy. It can't happen. Your formula says it can't happen. And doing the simple math, your kinetic energy formula overtly says the spring has twice as much energy if it pushes the lighter object. All right. Let's see. I'm not ignoring anything. You didn't do any experiment. So again, the experiment's right on the board. It's not that complicated. We can all use our imaginations and figure out that, yeah, that all makes sense. I mean, Physics Girl didn't do the train experiment. None of these people do the experiment. And even if they, yes, there is video of that one. Okay, just pushing one car into another car. Okay, so that's clearly understood exactly what happens. I'm just arguing that if you do the inverse translation of that experiment, instead of losing half the energy, now they don't measure half the energy being right. They don't immediately take the heavy. When the two cars connect, they don't sit there and put them in a water bath and pull out all the heat to see if there's half the energy was lost. I mean, everybody who's rational already knows half the energy wasn't lost because you conserve the momentum. You can't conserve the momentum. That is, you can't transfer momentum from one cue ball to another cue ball, right? Pool ball. You can't conserve it and then say, I lost energy. So the fact is if you hear a sound, when the two balls hit each other and you hear a sound, it means this one's leaving a little tiny bit slower. You can't have it both ways. You can't conserve the momentum and then say, I lost half the energy. It's impossible. So if you made any sound, or you chipped the ball a little bit, or you pulled on the fabric, of the pool table, any of those losses mean this one's leaving a little bit slower. That's the fact. And you people are just so silly to think anything else is true. That I can transfer momentum and lose half the energy. It's idiotic, insane, crazy. It was crazy 200 years ago. It should still be crazy now. And I just can't believe that you think you could ever, if you really had to institutionally prove this, you actually had to go to the British Institution of Science there, and you had to actually show the experiments that would prove this nonsense, that you could actually do it. But you can't do it, because it's a ludicrous proposition. You cannot transfer 100% of the momentum and then claim, I lost a whole bunch of energy to deformation and heat and sound, and grandmothers fell over and all kinds of crap happened. I did all this extra work in the world, okay, with heat and energy and sparks and all kinds of other shit, but I conserved 100% of the momentum. It's a ludicrous statement. You people should all be shot for saying things this stupid. It's so stupid, the physics police should just shoot you. Okay, with some sort of bullet that doesn't kill you, but just puts a, just something to mark you, a little black eye or something, one of those little black things that go around your eye, just joke things. But I mean, you should be marked as idiots and morons. It should make one of those little spinning stupid hats pop out of your head. Fuck. Anyway. Where I say anything about the rate of deformation of the spring, as I said, inertial kinetic energy of the body 1 became deformation energy of the spring. So there's just no way to make any sense of that. So he's just trying to pretend that he threw the word deformation in, but he didn't mean deformation of the spring or the ball or anything. He didn't mean anything really got deformed. Deformation will not be any different from the light object going fast or the heavy object going slow. That's my point. Newton's second law says that if they have different momentum, they will compress the spring differently. So that's the joke, right? He's saying it overtly. It doesn't make any sense. Where are we talking about things with different momentum? The whole thing is a conversation about things that have exactly the same momentum, you asshole. The whole conversation is right that we're saying it's the same momentum. It's that your formula says there's a different amount of energy. So how can you type crap this stupid? All right, nowhere in the experiment is there any contention that the momentums are different. The whole conversation is about your idiotic notion that somehow momentum isn't energy, and the special energy formula says there's an extra place you can get energy from. Okay, they will compress the spring differently. Again, look at Newton's second law. So he keeps doing it. And the NASA website. Oh, guess what? Yeah, it's not even available today. So yeah, he put up these stupid links. Okay, none of them about spacecraft. So they're all about, turbine engines and different things. None of them about navigating in space. That was my analogy. I said NASA didn't use this bullshit to land on the moon. Okay, and now because NASA uses this bullshit to measure the speed of a turbine or something, somehow that means it's right and NASA believes in it. Okay, yeah, no it doesn't. Oh, somehow my link thingy ain't working. See, page not found. So I guess NASA doesn't really think much of those little educational pages, that they're not even available anymore. Yeah, so And he keeps claiming the one page has the formula on it when it has all the variables put right at the top. You know, what U means, V, D, 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 all the things, and there's no mass. There's no M. M equals mass. No, not listed. Anyway. Oh, these people are just, you know, this, you know, the other idiot, this Quexco guy. The reason the U.S. went to 5.56 bullet is because, among other things, a lighter, faster bullet can do more damage than a larger, slower bullet. So again, just just absolute bullshit, right? I mean, obviously there's certain advantages to fast bullets when you're, you know, targeting things. You're more likely to hit your target, right? The faster your bullet's going. And so there could be lots of reasons, but this whole idea that you think total damage is higher, that you can move more atoms, you can vibrate more physical substance by just going to a smaller, faster thing. You're really that stupid. So why don't they make wrecking balls out of fast stuff? You know, why don't we just swing a bunch of light stuff into buildings if light things just instantly create more energy? Oh, it's too stupid. All right. Okay, so I said and then I should. Okay, deformation. Okay, so different momentum will compress the spring differently. So again, he's making an argument that's nowhere in this subject. Nowhere are we arguing about things having different momentums. So again, if that isn't straw man nonsense, completely off the subject, a complete non-answer to my statement. Okay, to conserve momentum, the objects with half the mass must move twice as fast. So if you're going to argue you transferred the momentum, okay, 100% of the momentum, you can't change its mass, so you have to change its velocity. You can't avoid it. Newton's second law tells you that the momentum of body 1 and body 2 will not be the same again. So he's saying the momentums aren't the same when they are factually the same. MV, idiot. So he's saying that if I put the same spring compression with 1/2 the mass, he's saying this one of these won't be going half or twice as much as the other. That somehow I won't get exactly that as an outcome. That if I put half the mass, I'll get twice the velocity. He's saying that's Newton's law says that doesn't work. Of course, Newton's laws say exactly the opposite. And also Newton's second law, he's doing it again, gives you the same result with conservation of energy. So it's just absolute nonsense. Okay, and doing the simple math, your kinetic energy formula overtly says the spring has twice as much energy if it pushes the lighter object. That's the overt fact. It's saying pretty much you get twice as much out if you put a small object on the spring. Okay, no it does not. Yes it does. Okay, as I said, the body 1 had 250 joules of energy. This energy becomes deformation. What deforms? We're talking about like steel balls and stuff. What the fuck are you talking about? What deformed? Okay, energy of the spring. So he's saying again that somehow the energy is being lost because the spring is losing it in some other direction, or it's getting hot, or some other thing. How is this spring losing the energy? And where's your example of it anywhere in the universe? I mean, where do we have an example where we shoot a spring, we shoot a ball into an identical spring, and somehow we got half as much energy out of it? No, I can show you lots of examples of this, okay, where they put a little thing on an air track and they have springs at either end and they push it once and it keeps going back and forth, back and forth, back and forth like hundreds of times. How could there be any deformation losses in the spring if the same energy, you push it once and the same energy keeps going back and forth minus like 0.5%? You're just too stupid. These arguments are so frickin' stupid. You're such an arrogant, stupid, ignorant piece of shit. So I will have to just block you because you're just going to keep saying Newton's second law says something that's completely ludicrous. Newton's second law doesn't say you lose half the energy. And every physical experiment ever done with springs and tracks and balls will show you don't lose half the energy every time. If you lost half the energy, you could only push it and it would hit the spring and lose half the energy, and then it lost another half and another half. It could only go 3 times and it'd have to stop. You're just so full of shit. Okay. Deformation of the spring with a magnitude of 250 joules. So he's saying you lost half. He actually believes the heavier object means you lost half the energy just launching it. Just pushing it, you lost half the energy. When we know that can't possibly be true, because when it gets to the other side, it's going to recompress the spring the same exact amount almost. Tiny loss, 1%. It'll lose 1%. You're saying that 1% is really half the energy of the system, which is just idiotic, ludicrous, silly. It's such nonsense. I can't believe you people are such religious kooks. You're fanatic religious kooks. This defense of an impossible, silly circumstance. And you're just going to keep defending a stupid mistake. Physics obviously made a mistake. Newton was right. Leibniz was wrong. It's just a fact. And here you are, just, you can't believe it. You can't believe it. Your Pope is God. Your Pope doesn't make any mistakes. I mean, this is just disgusting. Yeah. Anyway. Energy of the second body, again, 250 joules initially, so you had 250 joules, and you end up with 250. Well, we know there's no ending up with 250. We know when the spring launches the two objects, your math says one object has twice as much energy as the other object, so you can't be making these silly statements that the math says is on your side. The math isn't on your side. You're just full of shit. I'm never even going to get to the video I was going to play, am I? Yeah, no, I guess I'll just do the comments. And we'll save that for the next time, or the next time. Alright, so this whatever, fuckhead. Sorry. I mean, no offense, but it's a silly fucking screen name. He made some other comment, okay? This long, drawn-out pile of shit. And, you know, it's just a rationalization for nonsense. So, I mean, I said to his nonsense, sorry, but this all sounds like a bunch of obfuscation. They are making direct statements regarding the amount of energy something possesses. Nobody allows there to be ambiguous dual statements about how much energy is in a cup of gasoline or a stick of dynamite, right? We don't have any fucking, you're not allowed to say, oh, well, the dynamite has 17 momentums, but it has 649 times more energy. We know it's dynamite's going to blow up a certain amount. We know gasoline's going to move your car a certain amount. You're not allowed to say, oh, there's a bunch of extra energy and you can, no, there's none of this horse shit. So it's just, this is just such bullshit. I mean, their physics is rigorous about this kind of stuff. Again, the French guy who they cut the head off of he already did all these experiments and proved that you can't kill this stuff. Okay, the matter and the energy is always conserved. They are explicitly saying things with the same energy, momentum, have different energies. They're explicitly saying it. So, I mean, again, he's just trying to make excuses. Like there's this is a useful formula for something, who knows what. As I pointed out, it can never give you the right answer, okay? I mean, the kinetic energy formula will never give you the right answer. Okay, I'll state again, there's no experiment you can link me to showing this fake kinetic energy beyond momentum being recovered. You'll never recover it, you'll never see it because it never happens. It's completely made up bullshit. You're ignoring the silly history of the stupid formula. So again, I pointed out the history. There's no good history here. The only reason why it's being believed is because they got fooled, like Ken Wheeler fools his little dupes with his ferrocell and talks about how light is bent and magnetic moments and all this kind of bullshit, right? And it's complete bullshit. They were fooled by a clay experiment. That's the true history, okay? There's no other history. There's no other point to be made here. Is this they think because something goes further through clay, fast things go deeper into it, that means it has more total energy. Okay, just like an idiot who would shoot things into gravity, and because the light thing goes higher, they'd say the light thing has more energy. Well, of course it doesn't. It's going to land with exactly the same spring you shot it with. I used the same spring, right? The same exact spring. The half-heavy object goes twice as high, 4 times as high. It's not, that's not the truth. It's not telling you it has more energy because when it comes back down, it's going to compress the spring the same amount. You know this. Why should I even have to argue this? This is a stupid, idiotic, moronic formula. It has no integrity. It has zero. There's no rational defense of its use anywhere. And momentum is always the truth. There's no example where momentum gives you the wrong answer. So why is there any argument here? Momentum always gives you the right answer. It always works. And here you are saying, I need this special wooey thing. Why do you need it? Anyway, you're ignoring the silly history of this stupid formula. You're ignoring the silly interpretation of experiments. You're just defending nonsense as somehow sensible to pretend the error isn't a real error. So I'll read this mush. Okay, he types the same mush on two different videos, the same little diatribe, but this one down here is the one I'll read. It's a different version of his mush. Yeah, here it is. Okay, read more. All right, DraftScience. The confusion in this issue comes from the similarities of the formulas. So there's no similarity. I mean, 1/2 and squared. A complete disproportion. All of a sudden, mass is half as valuable and velocity is, squared. I mean, mega multiplied. When Newton saw the universe as mass and velocity being equal, these lunatics see it as somehow velocity means everything and mass is, oh yeah, you need some, but you really don't like, mass, who cares? Anyway, the kinetic energy formula is a total buildup gained energy formula, which is absolute nonsense. We're talking about fucking asteroid traveling the same speed for 6 million years. What are you talking about? Total energy formula. What the fuck? This doesn't, a train going down the track, there's a total, and no, it's going 30 miles an hour. It's going 30 miles an hour an hour ago. It's going 30 miles an hour from now. What kind of horseshit evasion is this mush? In none of the examples could you any argument about, oh, it's only at this special moment it has twice as much energy. Oh, it's just too stupid. And the momentum formula, MV, is only a moment of energy. What does that even mean? It doesn't mean a damn thing. Nothing can deliver the energy in a moment, so to speak. All of it is an actual process. Even the ones that look instantaneous aren't instantaneous. Okay, so, but clearly some of them are really slow. You compress a spring, that's a pretty slow process. They are different things. How can they be different things? They're a definition of energy. And again, they're saying that the definition that works all the time somehow needs to be augmented by this magical living force bullshit formula invented by religious kooks. Okay, but both are related. How are they related to the idea of push? Well, how? How are they related? There's no way to make it make any sense. I have something going 30 miles an hour and it weighs a certain amount. They say it has twice as much energy as what the momentum formula says. The formula tells you how much it's going to compress another spring. They say it's going to compress the spring twice as much because it has twice as much energy as the other object that will compress the spring the same amount. I mean, it does. Hang on. There's no point. There's no point. It's just that one is the total, including acceleration. Acceleration has absolutely nothing to do with this shit. Nothing. We're not talking about how it got its velocity. We're talking about what happens when the two velocities collide. Anyway. And the overcoming of inertia. Well, newsflash, there's no such thing as inertia. Okay? There just isn't. It just takes time to fill a bucket. Okay? The bucket isn't saying, I'm resisting being filled. No, you have to actually pour the shit in the bucket until you pour it in. It's not resisting. I mean, there's a ton of examples where I can say when I go out to push something that's really light and it's like, oh, I can push it with my finger. There's no resistance. It just takes a little bit of effort to get the stuff into the other bucket. You have to make contact and you have to push it into the other bucket. But there's no resistance. And the other is a snapshot. So that's just horseshit. Absolute evasive mush. Has nothing to do with the controversy. It completely disrespects the whole frickin' fight, the history, the fact that the people did take sides. This isn't some who cares, it doesn't matter bullshit. This is a fundamental, important fact of what energy is. And their definition of it is that you can make it and create it without any consideration for connecting it to reality. Theirs is a free energy formula. It's the only way it could be understood. All I do is I compress a spring with a heavy object. with a specific momentum. I compress the spring with the heavy object, moving slow. Then I just replace the heavy object with a lighter object that's going to move twice as fast. And I release the spring. Their theory is I just doubled my energy for free. I got twice as much watts now. I can make a generator go further. I can make light bulbs burn longer merely by banging heavy things into springs and then releasing them with lighter things on the spring. I can do that all day long and just make free energy. That's their physics. That's what they're defending. They're overtly pushing it. They're shoving it in your face. They keep saying, Newton's second law. Again, wasn't Newton's formula. They keep bringing up Newton. Newton wouldn't agree with a damn bit of this, and these people all know it. If Newton was alive today, he would hate this formula invented by his worst enemy in life. So again, if we could dig up Newton, do you think Newton would say, oh yes, Leibniz was a charming human being, was quite brilliant? The guy who stole his calculus, right? The guy that he had the biggest fight with in his life with anybody that he had a fight with. He's going to say, yeah, this was a great idea. Yeah, and take my F equals ma and pervert the fuck out of it to make it, we made it mathematically rational. Newton would be pissed the fuck off. And you assholes pretending that this isn't in a controversy. This doesn't mean anything. Yeah, it's fundamental to understanding how the physical universe works. And this is just more of their wooey quantum relativistic horse shit. Again, I'll assert the formula has never gotten the right answer. You'll never show me an experiment where they collect this double energy. They'll never collect it ever. Because it's fake. Enough. Yeah, that's enough. All right. So till the next time and such, and so forth and whatnot. I really do hate people. Really do suck. People suck. There's nothing. All I can say is just suck. I'm sorry. You can't do that. You can't figure out this simple stuff. I mean, this really isn't brain surgery. It isn't rocket science. It isn't global economics. And you're not even trying to get the right answer.